Hello everyone, here in this section we have functions of several variables definition. Here we have D, and that is real numbers. So here in this part we have x1, comma x2, comma 3 dots, comma xn. And based on but on this part we have real numbers, we have function. So function of these real numbers, that is equal to w, and what we have here, this is our domain. So x1, x2 up to xn, this part is domain, and here it is w, that is our range, or f of x1, x2, xn, this is range, and w is dependent of f, so dependent of our function, and f is function of n independent variables, and that is from x1 to xn. And also we can say that these that we have here inside x1 to xn are input, and what we have for our function w, that is output. So in this part we have z equal to f of x comma y, and we have this point on this part, it is x naught comma y naught, and it is here inside. On this part on right side, this point is here on this line. So what I have here inside in port A, we call that interior point, and what we have here in port B, we call that boundary point. So interior point and boundary points of a plane region R, we have these two here, and interior point is necessarily a point of R. The boundary point of R need not belong to R. Now here on this part we have circle, and we have this set x comma y. Here we have x squared plus y squared less than 1. So this is less than 1, that means we have open unit disk, and every point is an interior point. For example, we have this point and it is here inside. Now on this part we have x squared plus y squared equal to 1. For example, we have this point here, and that is boundary. So boundary of unit disk. So here we have the unit circle. And finally here on right side we have x squared plus y squared less than equal to 1. Here we have less than equal to 1, that means we have closed unit. So closed unit disk, and that contains all boundary points. So this part is included, and that means all boundary points included on this point. So based on what we have on top, here we have definition. Point x naught comma y naught in the region R in the xy plane is an interior point of R if it is the center of disk of positive radius that lies entirely in R. And the point x naught y naught is a boundary point of R if every disk centered at x naught comma y naught, and that contains points that lie outside of R, as well as points that lie in R. And finally here we have the interior points of region as a set make up the interior of region. The region's boundary points make up its boundary. The region is open if it consists entirely of interior points. The region is closed if it contains all its boundary points. So this was what we had on this part. Here we had open, and this one was closed, and this is what we had for boundary. So again, this is based on what we had on this part was less than, this is equal to, and here is less than equal to. Note that when we have closed unit disk, it contains all boundary points. A region in the plane is bounded if it lies inside a disk of finite radius, and a region is unbounded if it is not bounded. Here we have another definition: the set of points in the plane where a function f of x, y has a constant value which is equal to c, so c for a constant, is called a level curve of f. The set of all points x, y, f of x, y in space for x, y in the domain of f is called graph of f. The graph of f is also called the surface z equal to f of x, y. Now here on this part we have example graph f of x, y equal to 100 minus x squared minus y squared, and plot the level curves f of x, y equal to 0, f of x, y equal to 51, and f of x, y equal to 75 in the domain of f in the plane. Based on what we have here, the domain of our function is the entire xy plane, and the range of function is the set of real numbers less than or equal to 100. And for our graph, we have paraboloid and z is equal to 100 minus x squared minus y squared. So based on what we have here, f of x, y equal to 0, the level curve f of x, y equal to 0 is set of points in the xy plane at each f of x, y equal to 100 minus x squared minus y squared. So this one equal to 0 based on what we had here on this part. So using what I had here, that one equal to 0, or so here we have x squared plus y squared equal to 100, and when we have on this part radius it is equal to 10, and here center it is 0, 0. So here we have circle of radius 10 centered at the origin. So now we're going to repeat this, and here we have 51, here is 75. So f of x, y equal to 51, and again use what we have here. So here we have f of x, y equal to 100 minus x squared minus y squared equal to 51, or we have x squared plus y squared equal to 49. So this means here we have a circle of radius 7, and the center it is 0, 0. So it is centered at origin. And do the same thing on this part, f of x, y equal to 100 minus x squared minus y squared, but in this case we have this equal to 75, or x squared plus y squared equal to 25. So here we have 100 minus 75, it is 25, and 25 it is 5 squared, so radius it is 5, and center it is based on what we have here, so it is 0, 0. So here we have the circle of radius 5 centered at the origin, and the level curve f of x, y equal to 100 consists of the origin alone, because here we have f of x, y equal to 100 minus x squared minus y squared equal to 100, or it is x squared plus y squared equal to 0. And if x squared plus y squared goes to 0, then the values of f of x, y are negative. Here we have example, for example, the circle of x squared plus y squared equal to 121. Based on what we have here, this is circle with radius 11 and center it is 0, 0. This gives the constant value of x, y equal to negative 21. So here we have negative, and that is the level curve of f. So based on what we did on this part, here is our graph. Here is f of x comma y equal to 0. And this is when x squared plus y squared it is equal to 100. That means, and this means radius it is equal to 10. So this is 10. And for when we have f of x comma y equal to 51, our radius was equal to 7. So here we have 7. And finally, when we had here f of x comma y equal to 75, we had x squared plus y squared equal to 25, and for that part, radius was equal to 5. And for all of these, we had center 0, 0. And for when we had f of x comma y equal to 100, we had only this point, origin, because we had x squared plus y squared equal to 0. Definition: the set of points x comma y comma z in space where a function of three independent variables has a constant value f of x comma y comma z equal to c. So c for constant is called the level surface of our function, so level surface of f. Under definition, so here in this part we have this point x naught, y naught, z naught in the region R in space is an interior point of R if it is the center of solid ball that lies entirely in R. And the point x naught, y naught, z naught is boundary point of R if every solid ball centered at x naught, y naught, z naught contains points that lie outside of R as well as points that lie inside R. And the interior of R is set of interior points of R. The boundary of R is set of boundary points of R. The region is open if it consists entirely of interior points. The region is closed if it contains its entire boundary. Find and sketch the level curves f of x comma y equal to c on the same set of coordinate axes for the given values of c. We refer to these level curves as a contour map. So here on this part we have this function f of x comma y equal to 1/5 multiplied by x squared plus y squared. And here we have c equal to 0 and 3, 6, 9, 12. So when c is 0, then we're going to have our function as follows. So here we have 0 equal to 1/5 times x squared plus y squared, multiply both sides by 5. So we're going to have 0 equal to x squared plus y squared. And the only solution to this equation is when x and y are both 0. So this is the equation of the point 0, 0. So based on this, this is what we have on our graph. Origin 0, 0. And for when we have c equal to 3, here we have 3 equal to 1/5 multiplied by x squared plus y squared. So here again, to clear this fraction, multiply by 5. On this side we have 15 equal to x squared plus y squared. So based on what we have here, we have circle and center is origin 0, 0, and radius it is square root of 15. And here is our circle based on origin 0, 0, and radius is square root of 15. And here I did the same for c equal to 6, c equal to 9, and c equal to 12, and based on that, here we have 30 equal to x squared plus y squared. Then for c equal to 9, we have 45 equal to x squared plus y squared. And for c equal to 12, we have 60 equal to x squared plus y squared. And here we have radius for each one of these. So we have the first one that was radius equal to square root of 15. And we have 3 larger circles. So this one here, and here, and this part. So we have larger radius based on what we had for C. So this is our graph. Now here it's asking to find and scale the level curves f of x, y equal to c. The same set of coordinate axes for the given values of c. So here we have f of x, y equal to the square root of 32 minus x squared minus y squared, and c is 0, 1, 2, 3, 4. So based on what we have here is square root. So the domain of f is set of points x, y satisfying. We're going to use what we have here as a radical 32 minus x squared minus y squared. That should be greater than equal to 0. So simplify here is x squared plus y squared less than equal to 32. So we have this one. And the range of f is the set of real numbers less than or equal to what we have here is 32. So less than equal to square root of 32, which is equal to 4 times square root of 2. Now to find the level curve and c is equal to 0. So to find the curve c equal to 0, we're going to use f of x, y equal to 0. So here we have 0 equal to square root of 32 minus x squared minus y squared. So this is 0 equal to, using square on both sides. So here we have 32 minus x squared minus y squared. So based on this, we have x squared plus y squared equal to 32. So here we have circle with radius 4 times the square root of 2. So here we have this circle, center is 0, 0, and radius is 4 times square root of 2. Now c equal to 1, so we have 1 equal to square root of 32 minus x squared minus y squared. So that's 1 equal to 32 minus x squared minus y squared. And here we have x squared plus y squared equal to 31. So here we have circle centered at origin 0, 0, and radius it is equal to square root of 31. And here is our graph based on these two steps, c equal to 0 and c equal to 1. So for one of these we had, the first one we had radius equal to square root of 32, which was equal to 4 times square root of 2, and for second part we had radius equal to square root of 31. So here is where we have two circles. And here is c equal to 2, so we have 2 equal to square root of 32 minus x squared minus y squared. And so I'll make this radical. Here we have, so use power. For all of these, we get the same to eliminate this radical. So here we have 4 equal to 32 minus x squared minus y squared. And simplify, here we have x squared plus y squared equal to 28. So here again we have circle centered at origin 0, 0, with the radius it is equal to square root of 28, which is equal to 2 times square root of 7. So here we have another circle on this part, and it's this one we have here with radius 2 times square root of 7. And here again, we repeat. So we have c equal to 3. 3 is equal to square root of 32 minus x squared minus y squared. So here we have 9 equal to 32 minus x squared minus y squared. Simplify. Here we have x squared plus y squared equal to 23. So here again, we have circles centered at origin, and radius is equal to square root of 23. So I added outer circle on this part. And then for c equal to 4, here we have 4 equal to square root of 32 minus x squared minus y squared. So it is 16 equal to 32 minus x squared minus y squared. Simplify. It is x squared plus y squared equal to 16. So here again, we have circles centered at origin, and radius it is equal to square root of 16, which is equal to 4. So here we have all these circles in same set of coordinate axes. So our graphic is now the contour map for c equal to 0, 1, 2, 3, and 4. Given the function f of x comma y equal to 1 over square root of 81 minus 9x squared minus 9y squared, answer the following questions. Part A, find function's domain. So here when we have in denominator, it is a square root, and usually for square root, when we try to find domain, we use when we have here inside radical and that one greater than equal to 0. Because of having this in denominator, we cannot have this equal to 0. So here is 81 minus 9x squared minus 9y squared greater than 0. So here is negative 9 x squared minus 9y squared greater than negative 81. Now factor of negative 9. So negative 9 multiplied by x squared plus y squared, that is greater than negative 81. So divide by negative 9, where we have x squared plus y squared less than 9. So we divide by negative number, that's why we change direction of inequality. So the domain of the function is set up all points x, y that satisfy x squared plus y squared less than 9. Part B, find the function's range. First, find range of square root of 81 minus 9x squared minus 9y squared given the domain x squared plus y squared less than 9. So to find range, use algebra to manipulate the left side of x squared plus y squared less than 9 to look like square root of 81 minus 9x squared minus 9y squared. And note that x squared plus y squared is never negative. So here I'm going to have x squared plus y squared greater than or equal to 0, and it is less than 9. Now I'm going to multiply by negative 9. So negative 9 times 0, negative 9 times x squared plus y squared, and negative 9 times 9. Because of multiplying by negative number, we should change direction of inequality. So here we have negative 81, but we should change this less than to greater than. That's why we're gonna write negative 81 here. And then we have negative x squared minus 9y squared less than or equal to 0. So what I did on this part, because of multiplying by negative 9, I had negative 81, change that direction, then I have this one, So I had this, but I didn't want to write that way. So I switched order. And then add 81 to all parts of this inequality. So adding 81, here we're gonna have 0 less than, we have 81 minus 9x squared minus 9y squared less than or equal to 81. Now take square root from all parts of this inequality. So here is 0 less than square root of 81 minus 9x squared minus 9y squared less than or equal to 9. So the range of square root of 81 minus 9x squared minus 9y squared is 0, 9, and here we had 0 less than, and here on this part we have less than or equal to. So here we have parentheses 0, 9, close bracket. So based on what we have for range of square root of 81 minus 9x squared minus 9y squared, this one was in denominator. We can find what is range for our function. So the closer the value of square root of 81 minus 9x squared minus 9y squared is to 0, so meaning that if our denominator was close to 0, the larger the value of the function. And the closer the values of square root of 81 minus 9x squared minus 9y squared are to 9, that means what we have for our function that is closer to 1 over 9. So the closer the function is to 1 over 9. So range of function is bracket 1 over 9, comma, infinite. Part C, describe the function's level curves. So this part for the equation of function, the level curves have equations of the form c equal to 1 over square root of 81 minus 9x squared minus 9y squared. So what we have here is c equal to f of x comma 1. And here c is greater than or equal to 1 over 9, and this is because the range of the function is this part we have greater than or equal to 1 over 9. So this part, let's c equal to 1. So we choose different values of c to plot the level curves of the function. So here we have 1 over square root of 81 minus 9x squared minus 9y squared equal to 1. So this is square root of 81 minus 9x squared minus 9y squared equal to 1. And eliminate this square root. So here we have 81 minus 9x squared minus 9y squared equal to 1. And now subtract 81 from both sides. We have negative 9x squared minus 9y squared equal to negative 80. Factor of negative 9. So here is negative 9 times x squared plus y squared equal to negative 80. And solve for x squared plus y squared. So here we have x squared plus y squared equal to 80 over 9. So that's why we have circle centered at origin, and radius it is equal to square root of 80 over 9. So that is equal to 4 times square root of 5 over 3. So choosing any other value for c, where c is greater than or equal to 1 over 9, we will have a circle of different radius, but it is again centered at 0, 0, so centered at origin. Therefore, the level curves of the function are circles. And since the domain of function is set of all points x, y that satisfy x squared plus y squared less than 9. The circles that are the level curves of f of x, y will have to have radius less than 3. So based on what we had here, if we try to find radius that is less than square root of 9, so it is less than 3. Part D, find the boundary of the function's domain. The domain of the function is a set of all points x, y that satisfy x squared plus y squared less than 9. So we had this part before. Since the smallest circle that contains the entire domain is a circle centered at origin of radius 3, the boundary of f of x, y is a circle x squared plus y squared equal to 9. So what we have here is a disk containing each point in the circle x squared plus y squared equal to 9, and that will also contain points inside the circle and points outside the circle. So inside the circle means points in the domain, and outside the circle it is for points not in the domain. Part E, determine if the domain is an open region, closed region, both or neither. Since the domain of the function is x squared plus y squared less than 9, and the boundary points are all points in the circle x squared plus y squared equal to 9, the domain contains none of its boundary points, and this means the domain is open. Part F, decide if the domain is bounded or unbounded. The domain is bounded, so all the points in the domain of f of x, y satisfy the equation x squared plus y squared less than 9. So any circle centered at the origin with radius greater than or equal to 3 will contain the domain.